Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials and nanoscience. Hi everyone, today we have with us Laia Castilla Amoros from EPFL in Switzerland. She is a doctoral assistant in the lab of nanochemistry of energy, and she's speaking to us from Switzerland right now. Hi Laia, how are you doing today?
Hello, Pranati. I'm fine. How are you?
Wonderful. Looking forward to speaking with you. So let's begin by understanding your current research. So could you explain your research in like super simple words to us?
Okay, I'll try. My research is based on the synthesis development of multimetallic colloidal nanoparticles.
Okay.
While with colloidal chemistry, there's been only possible to achieve up to three metallic nanoparticles that usually contain at least one noble metal.
Right.
I'm pushing to obtain copper-based and noble metal-free multimetallic nanoparticles for their use as catalyst for electrochemical CO2 reduction, in which,
Right.
well, I choose copper because it's a very promising material, and I will talk about it more during my week.
Okay, well, awesome. That's a very nice segue to the next question, or the next thing that we want to learn is, what would you be curating? What would you be talking about when you are curating? What can the followers expect?
Okay. I'm planning actually to focus more on colloidal chemistry as a platform for material tuning and properties research. I like to first talk about what I am and make an introduction of what is colloidal chemistry and why you should care about it as a nanoscientist.
Right.
After that introduction, I like then to show some of the many beautiful things you can do with colloidal chemistry, and then focusing more on the properties of this bottom-up technique for nanomaterials that allows shape, size, and composition control. And then, including metal synthesis, but also metal oxides, so metal sulfides and perovskites. And then, I like to introduce some of the applications of colloidal nanoparticles, like, for example, in solar cells or in water splitting or devices or CO2 reduction.
Okay, so it sounds like a very action-packed week and a lot to look forward to, a lot to learn about. So thank you very much, Laia. We are looking forward to your time on Real Scientist Nano.
Thanks for the opportunity to share my work and my passion too. No,
No worries. Thank you for listening. To know more about us, please visit our website, realscientistsnano.org, and follow us on Twitter at realsci_nano.